Okay, so this is the experiment, properties of gases. This lab is going to be a virtual lab, so you needed to watch this video and pose very often to answer questions in the lab report. Okay, now I'm starting the part A. We'll study the properties of a carbon dioxide. Now I have a candle ready. I'm going to put the baking soda into it, on the bottom of it. So this is baking soda. It's about 10 grams, so I will just shake some on there. And we need to add a vinegar. If we play this at home, add vinegar, and then we'll get a carbon dioxide, and then react with the baking soda. So we'll add some. And so we'll also check the property of the carbon dioxide. So we're gonna ignite the candle. Now watch closely. We dump the vinegar in there. You can see there's some gas bubble. We don't have enough the baking soda. Okay. Now notice what happened. Okay, now let's try to reignite the candle, see if it's possible. See that? Or do it again. So you're gonna understand, you're gonna think about why. Here it's ignited. But when I approach down here, it's gone. So you should think about what's in there and why I cannot relight the candle. Okay. Now this is the part A, step 1 through step 5. Now I'm going to do a Ziploc bag, put some dry ice in there. The dry ice is the solid state of the carbon dioxide. So I'm going to put the dry ice into the Ziploc. Okay, so you can see the piece of the dry ice is already in there. Okay, so now outside the temperature is quite high. You can see what's happening now. It's going to be very quick. Do we see any liquid form? We don't. So this is a solid directly changed to what in there? You can feel something in there, right? Since it's not totally empty, other than the dry ice, there's something else in there. You cannot press it. Okay, so that's the behavior of the carbon dioxide. When it's very cold, it's solid. When it's warm up, they directly change to the gas form without the liquid form. Okay. All right. So that's the part A. Now let's move to part B, Boyle's law. Now you can see in step 1, we needed to do some setup to change the pressure of the environment. So here is the setup. So we should have our container, sidearm flask, put the balloon in there. It's already below a little bit, so there's some gas in there. That's the gas we're studying. Here's the aspirator. We connect that and seal the whole system. Okay. When I turn on the water, water will flow down. When water flow down, they will draw the air out of the sidearm. So the air is drawing out of this container. What does that mean? Less air molecule, less collision of the air molecule on the wall, on the balloon. So the pressure will be decreased. Okay, then you will see what happened to the balloon. Okay, now watch closely of the balloon. What is that? The size change. Okay, pretty much amazing, right? When I turn it off, just keep that way. But now if I open this, you can see this is another change of it. Now I draw air out, less air, but now I will let the air into the flask. Closely watch the balloon. Just suddenly shrink. Okay, so this tests our Boyle's law. All right. So I'm going to still use this setup for our part C. So I need to get the balloon out. Balloon is out. Now I'm going to put some carbonated water into the flask. Put the flask in. Still need the same setup. So now if I turn the water, you know what's going to happen. We've already explained that part B, okay? Now you will notice here's the some drink with carbon dioxide dissolved into it, okay? But now you can see some bubbles already out because I shook it, okay? But now notice the pressure change when I open the water. See what's happening? What's happening? Something ejected out of the liquid, right? What's that something? Okay, now it's done. Let's even join it outside. Okay. So when I open that, so that's opposite of the pressure change. So I increase the pressure. See what happened? Some of the bubbles immediately gone. Some of them get out of there, some of them go back to the liquid. So that's our Henry's law. Okay. Oh, take a look at the dry ice thing. It's already, they will blow, they will give us a explosion. So I will just relieve the pressure here. So you feel the pressure, that's from the gas, okay. All right, so Henry's law. Now let's move to Charles' law, part D. All right. Now we needed to have the setup on the fume hood. Now one is the hot water, one is a very cold liquid. Okay, if you want to see how cold the liquid will be, we can take a look at the temperature. Negative 56.8, 57 degrees Celsius. So that's very, very cold liquid there. How did I make it? I put some isopropyl alcohol is in there, like a rubbing alcohol, and I put some dry icing there to lower the temperature. Okay, so we have a very cold temperature tank, very hot temperature tank. This is almost boiling water. Okay, now I put this tank, this flask into the cold tank. So I will cool the air inside. Okay, then I will use a balloon to trap the air inside. Okay, so I'm going to take this out. It's quite cold now. I'm going to put the balloon on the top of it. Let's trap the air in. It's broken. Okay. Give it a water. Okay, so it's very, very cold. Okay. I will leave this in the air a little bit because I don't want it to put the very hot one too quick. just leave this in the room temperature for a while. Okay. All right, now come here. It's free, it won't break. A little bit. Okay, so that's fine. So I'm warming up this container, which means I'm warming up the gas inside of the container. It's trapped. Now notice the balloon's behavior. What happened? In the air, okay, this is a temperature change influence the volume of the air. It's not leaking, right? You see the difference? I'm going to put this back into the cold water tank again to let you see the difference of the balloon. Okay, so it's hot to cold. So let me make sure it's not breaking the flask. A little bit of time. What's this? Size of the balloon. It's already softened. It's no longer strongly expanded. Okay, see the difference? Feel the air. What happened inside of the air? Inside the container, the air's behavior. Okay. All right. So this tests our Charles' Law, Part D. Okay. Now, let's move to the part E, pressure and temperature relationship. Here we're going to use 3 different temperature and we'll test the pressure. So the pressure will be tested by this meter. The air trapped in here, this bowl. So we're going to merge the bowl into the cold water, cold liquid tank, the hot water tank, or leave it in the room temperature. So you got the 3 temperature, then we're gonna check the pressure of this gas. Okay, so the reading of the meter will be part of this lab. You're going to read this meter according to different temperature. I will give you very close the image of it. So you're gonna read how to read this meter. So you're gonna get the black one. The unit will be Pascal, PSI. Okay, and the inside will give you just another unit. It's a bar. Okay, inside you see the color. It's a little hidden in there. It's blue color. But now we're going to just read the black. It's bigger. It's easier to read. And this Pascal is the pressure unit that we're talking about in the lecture. Okay, so now our first temperature we wanted to measure would be the room temperature because it's stay in the room for quite a while, so it's very stable. What's the room temperature? We need to grab a thermometer. Okay, this. Is that possible? We get a very clear view of it?
Yeah.
Okay, so now this is a room temperature. Okay, so no. Temperature may be hard, or maybe I will tell you the temperature if it's hard to read. No. Okay. So let me read the temperature for you. This is the room temperature. So the room temperature is 21.9 degrees Celsius. Again, 21.9 degrees Celsius. Okay, so that's the room temperature. What's the pressure now? You needed to read this. That's a room temperature pressure. Be careful. You needed to read all the graduate marks and the 1/10 of the smallest graduate mark. Okay, is that possible? Okay, so pause here, read this, and put down the number in your report. Okay, now let's put this into our extremely cold liquid. Okay, first, what's the temperature of the cold liquid? Okay, I'll get the temperature first. So this is a digital one, so you can read the digital. So make sure it's negative 38. Oh, it's keep changing. Let's get it stabilized and we'll get a number. Okay. 46.6. I think it's stabilized. Negative 46.6 degrees Celsius. Let's check the pressure. What's the pressure in there? You will not read until it's stabilized. So you can see the pressure keep changing, right? Okay, once it's stabilized, we'll give you a clear view. Then you're gonna post there and get the reading and put down in your the lab report. I think now it's stabilized. You got it? Good. Okay, now that's the another temperature, the second temperature. Now I'm going to take this out. I'm going to put this in the boiling water. Okay, so put it carefully. It's almost full. Okay. Same thing, we needed to leave it there for a while. Let it stabilize. You notice the pressure keeps increasing. Until it's stabilized, you will look at the clear view. Post there, get the reading, and write down your lab notebook or the report. Good. All right, now it's done. I'm going to put this back. All right. So now you should have all the necessary data to make the curve and to find out the absolute zero. Okay, so that's this experiment 10's the demonstration.